All right, here we go. So this is 2017, number 3. I'm going to do the work on here, but then I will also post a picture of my work a little bit more neatly. And as I go through this, I'll also tell you the point values for each part. Okay, really common question here as well. This is what we would call like a fundamental theorem question and maybe Leibniz law as well. So we have this graph of f prime. It's important to see that this is f prime. The function is differentiable from -6 to 5 and satisfies the condition that f of -2 is 7. So we're probably going to have to come back to that. The graph of f prime, the derivative of f, consists of a semicircle and 3 line segments as shown in the figure. Find the values of f of -6 and f of 5. Okay, I don't think we've done one like this together before. So I'm going to come up here for part A. If they want me to find f of -6, and all I have is a graph of f prime, I want to remember that if I take the integral of f prime, that tells me how much f changed. So I have a starting value, just like the bananas problem the other day, or that was part number 2. When I integrated the rate in which people removed bananas, it gave me how many bananas were removed, or, pardon me, how many pounds of bananas were removed. It's the same thing here. If I integrate the derivative of f from something to something, that'll tell me how much f changed. To do this, I want to consider this starting information. So I know that f of -2 is 7. I want f of -6 and f of 5. Let's first think about f of 5. It's a little bit easier to conceptualize f of 5. That if I integrate f prime from -2 to 5, I'm going to get how much change there is in f from -2 to 5. These are x values, -2 to 5. Well, if I can find out how much change there was from -2 to 5, I can add that amount of change on to 7, because 7 is where I start. You might want to back that up, and I'm going to say it again. If I want to find out what f of 5 is, I need to figure out how much did f change from the x value of -2 to my x value of 5. So I'm going to integrate f prime. That tells me how much f changes. And I'm going to integrate f prime from -2 to 5. That'll tell me how much f changed from -2 to 5. I'm going to take that amount and add it on to 7, because 7 is where I start. I start with a y value of 7. This will tell me how much my y value changed, and then I'm going to add that on. So anyway, I hope that that makes some sense. I'll go over it again with f of -6. So this is a no calculator question. A calculator wouldn't help you on this part anyway. So I'm going to have to integrate from -2 to 5. So -2 to 5. I have the area of the semicircle, and I have the area underneath this triangle. So the semicircle is going to be 1/2 times pi times the radius squared. The radius is 2. And then the triangle is going to be 1/2 times the base, which is 3, times the height, which is 2. So this is going to give me 2 pi plus 3. So that's the integral of this plus another 7. So I'm going to have 2 pi plus 3 plus 7. So 2 pi plus 10. And I'm just looking back. Oh, dang it. You know, what did I forget to do? I forgot to make the semicircle negative. So this amount is negative. So let me erase. Okay, so actually this is -2 pi plus 3. So sorry, I didn't need to change too much, but -2 pi plus 3 plus 7. So -2 pi plus 10. All right, for f of -6, So this one was f of 5, part A. For f of negative 6, I'm going to do the same thing. I'm going to say, all right, I know where I'm starting. I'm starting in an x value of negative 2, and I want to go to an x value of negative 6. You can think about this in a few different ways. You can decide to like make your limits of integration the other way. I like to just stick to my standard way of thinking where the x value of negative 2 gave me a y value of 7. So I'm going to start there and add on however much change there is. And this change might be negative. So let's see what happens when I go, integrate. I'm not even going to worry about having that. Okay. So now I need to integrate from negative 2 to negative 6. So I'm going to have this triangle, 1/2 base times height. So 1/2 times 1, 2, 3, 4 times the height of 2. So all in all, I have an area of 4. But remember, when I go backwards or when I integrate from right to left, the area above the axis is now negative. So this area from negative 2 to negative 6 was above the x-axis, but I went in the opposite direction that I read. So this is negative 4. So we have 7 plus negative 4, or a total of 3. Okay, so those two parts, you get 1 point for this answer, 1 point for this answer, and 1 point for remembering to use the initial condition. So if you had just said part A, the answer was negative 2 pi plus 3, I think you would have gotten the point. And if you had said this answer was just negative 4, you would have gotten the point. This other point came from having them totally correct, which was remembering to add on the 7. Okay, so that is part A. I'm going to erase some of this so I don't have it all over the place. I don't know if there's a way to just like fast forward this part of the video. Or we could sing, it's bananas, B-A-N-A-N-A-S. Okay, hopefully that's good enough. Okay, on what values is f increasing? So we probably have done this one before when we were studying this stuff. So on what values is f increasing? So let's go back to what we know. F increases when f prime is positive. So where is f prime positive? F prime is positive from negative 6 to negative 2, and from 2 to 1, 2, 3, 4, 2 to 5. So that's it. They also wanted me to justify my answer. So f increases when f prime is positive is enough of a justification. That's all you really need to say. And you get 2 points for that. So now hopefully we've done 5 points worth that you feel pretty confident that you could get correct. Maybe this isn't so bad. Okay, part C, find the absolute min. I'm going to blue. Find the absolute minimum value of f on the closed interval from negative 6 to 5. Okay, so we're going to have to think about the endpoints here and the critical values. So first of all, f has an absolute min when f prime changes from negative to positive. So are there any places on this graph where f prime changes from negative to positive? Yes, right here. So we have, for part C, we have a potential min at x equals 2 because f prime changes from negative to positive. But I also have to consider the endpoints. It's just fun to write with this. Okay, so you've got to consider the endpoint. So now we need to make a little chart. And we need to talk about what x values are our potential candidates for maxes for our absolute min. So our potential candidates are x equals 2, because that's where the derivative changes from negative to positive, and that's the only place. And I have to consider the endpoints of -6 and 5. So -6 and 5, I already know what those y values are, right? Didn't I already find them in part A? So I know I erased it, but I have it over here. So f of -6 is 3, and f of 5 is 10 minus 2 pi, or -2 pi plus 10, either way. So all I really have to figure out is what is f of 2. So let me just make myself some space. So I have to figure out what the heck is f of 2 so I can decide if there's a min or a max, or so I can decide which is the absolute min. So f of 2 is going to equal, go back to the same way I was thinking in part A, is going to equal 7 plus the integral from -2 to 2 of f prime. Because I know where I start, so I have to figure out where am I when I end. So from -2 to 2, I have just the semicircle area. So I'm going to have 7 plus that, what was it? Just 2 pi. But remember that 2 pi was under the x-axis, so 7 plus -2 pi, or 7 minus 2 pi. So that is the value here. Now, we don't get a calculator. Which is the absolute minimum value? So which is the smallest? 7 minus 2 pi, 3, or 10 minus 2 pi? Keep in mind, pi is around 3 point whatever. So this is like 7 minus 6. This is like 10 minus 6. So the smallest number here is going to be the 7 minus 2 pi. This is going to be my absolute min. When it wants the absolute min, remember they want the y value. So the absolute min is 7 minus 2 pi. That is the absolute min, not 2. It happens at x equals 2, but the min is the actual y value. Justify your answer. All of this is a justification. There's a potential min at x equals 2 because the derivative changes from negative to positive. We also have to consider the endpoints. So once I consider the endpoints, as long as I have this labeled, if you don't have this labeled with x and f of x, this chart means nothing to the reader. But as long as you have it labeled, then you're good. Okay, that is worth 2 points only. So there's another 2 points. So now we have 1, 2, 3, 4, 6, 7 total, and we just have our last part to do. And there's always something that's a real gut check. So this one is probably part D going to be the part that's the most complicated. Give myself some space. Oh my gosh. There's got to be a way. I got to figure out how do I uncanny erase a big chunk at one time. Okay, here we go. For each of the second derivative of f at -5 and the second derivative at 3, find the value or explain why it does not exist. Oh, we can do this. Easy peasy. Not as hard as I thought. So we're looking at the first derivative. So the second derivative at -5 and the second derivative of f at 3. So let's go to -5 first. 1, 2, 3, 4, 5. So I'm here. What is the second derivative? So this is a picture of the first derivative. So the derivative of the derivative, we have a slope. We have to find the slope of that segment, which we can do. Looks like we are down to 1, 2, 3, 4, down to over 4. So we are -1/2. And the slope of the function at 3, 1, 2, 3. Okay, well, we are at a corner, so I can't take the derivative of there. So this derivative does not exist because f prime has, you can say, a corner. at x equals 3, or you could just say f prime is not differentiable at x equals 3. Either of those would work. 2 points. Yay! Good job, everybody. All right, I'm going to stop this one, and then I'll go do the next one.